this is the AQA, Functional Skills Level 1, Paper 2, in other words, the calculator one. This is the one for February 2021. So let's have a go. Section A, first question, is asking for an obtuse angle. Remember, obtuse angle is bigger than 90 degrees but less than 180. So it's something bigger than 90. So that's not bigger than 90. That one's looking hopeful. That's bigger than 90. That's too big. It can't be more than 180. And that one's far too big. So the answer is 95. Question 2. Question 2 says, here is a scale. The scale is 1 centimetre, represents 4 kilometres. What does 7 centimetres represent? In other words, we have 7 of these, which means we have 7 of those. So what we have to do is we're going to say 7 lots of 4 kilometres. It's a calculator one, so remember you can take your calculator and do 7 times 4. You should know your times tables, which will be 28, but if you don't, use the calculator and it will tell you it's 28. So in this case the answer is 28. Remember the units, it says what does it represent? It represents kilometres. So we must write that kilometres there, otherwise you may not get the mark. Question 3. Question 3 is talking about rounding 57.486 to 2 decimal places. Now remember, when you do that, you're looking for 2 places after the decimal point. So we have 1 place, 2 places, which means we're going to cut off after the 8. We will now look at the number afterwards. That's a 6, which means we will round upwards, which means we're adding 1 to the 8, which means we'll end up with 57.49, because I've added 1 to the 8, so it goes up to 9. If that's less than 5, we would not do that. Question number 4. Question number 4 is a conversion one. It's asking us to change 174 millimeters to centimeters. And remember that you need 10 millimeters to make 1 centimeter. In other words, we have to divide by 10 to change into centimeters. So you divide by 10. You can use a calculator or you can do it in your head. You have 174 divided by 10, which will give us 17.4. If this were a non-calculator one, it would be a matter of basically dividing by 10, which is a 0, and you divide by 10, which means you'd go along and put the dot after the 17. Question 5 is putting numbers in order, and they're asking us to start with the largest, so we need the biggest one. Now remember, on the number line, when you have a number line, the numbers get bigger as you go in this direction, and when you go that way, they get smaller. 0 is here, so you basically go things like 1, 2, etc. On this side you go -1, -2, etc. So if we're starting for the biggest, we want the one that's most positive, and the biggest, most positive one there is 6, so that's the largest one we have. As we go backwards, we would go 6. The next positive one we have is the 1. We're now working with negatives, and the largest negative is the thing that's closest to 0. So like -1 or -2 or -3. Here you notice we have a -3 or -3. Then we'd have the -4. And the smallest one we have would be -7, because it's the one that's most to the left on the number line. 2 marks for getting those all in the right order. Question 6 is about drawing a line from each of the shapes they've provided to the number of symmetry lines we have. And so it's a full page question, as you can see. And so we need to think about how many symmetry lines each shape has and then join it to the correct answer. Now an isosceles only has 1 symmetry line, and to show you what it is, it would be something that looks a bit like that. Okay, so we want to connect it to the number 1, and the number 1 is over here. So let's connect them with a line to basically show the answer. Okay, we move down. The next one's a parallelogram. Now parallelogram has no line of symmetry, because if you were to draw the line of symmetry like that, that corner, when you fold it, would not match this corner. It would be somewhere over here. And if you were to fold it like down the middle here, this side was too short compared to over here, so again they wouldn't match up. So in this case there's no lines of symmetry, which means we're going to join it with the one up there. So So we want to match it up with the 0. Okay, we're now left with the final shape, and the final shape is a square. Now a square has 4 lines of symmetry because you can fold it along the middle there. You can fold it along the middle there. You can also fold it from corner to corner. And you can also fold it from corner to corner. You can't do that with a rectangle, but you can do it with a square. So in that case you have 4 lines of symmetry, and 4 is over here, so we can just join it up with a line. Very good, that was question 6. Let's move on to question 7. And question 7 is a 3-mark question, and they're asking us to work the perimeter. Now the perimeter is all the way around the outside of the shape, and as you can see we have the information for most of the sides, but we're missing the distance along the left hand side of the shape. So that's for our job to find out. Now the way we do that is we see what matches up. So if you think about it, this side here from the bottom to up, this bit here is 2 centimeters, which means going from up here to there would be 2 centimeters. This bit here going from up there, that bit on the right hand side going up is 9, which means that this bit here on that side would be 9. So total distance would be 2 plus 9, 9 plus 2, you can use a calculator, you can just count up to give you 11. So on this side we have 11. So when we do our perimeter will be adding up all the sides. Sorry, let me make sure it's aligned. It's a bit crooked. There we are. So the perimeter is adding all the sides. So we have 5 along the top, 9 along the right hand side, then a 3, then a 2, then an 8, and finally an 11. Write it all down, we get 3 marks to show that you know what you're doing. Now we can do it 5 plus 9 plus 3 plus 2 plus 8 plus 11, showing all the calculation there, which means when we add it together, we end up with 38, as you can see. So the answer is 38. Write your answer in the answer box and check that they have put the units they have in this case, so you're fine just writing the 38. But you're showing your method. It's always a good idea to show your method. Okay, so that was section A. Section A are the shorter questions. We are now moving on to section B, which are the longer questions, and they're sometimes related, part A, part B, etc. As you can see here, we're on supermarket, part A, so that means the other questions might be also. It's a 5-mark question. As you know, it's going to be more marks. So we need to show our workings. As you can see here, it says you must show your workings. So we're going to have to show how we do our calculation. What's this question about? It says there are 2 supermarkets and they have offers on the tins of tomatoes, offer A and offer B. Offer A states that every tin per tin costs 83 pence. You buy 1 and you get 1 free. Offer B says that the cost of 1 tin is 59 pence, and if you buy 3 tins, you only pay for 2. Or in other words, you get 3 tins for the price of 2. They tell us that all the tins are the same. A customer wants to buy 12 tins. That's a key bit of information there. She wants to spend as little as possible, so basically paying the smallest amount. Which offer should you choose? Offer A, offer B, and we need to show our workings. So let's have a look. Offer A. What does offer A says? Offer A says you buy 1, you get 1 free. So if you're buying 12 tins, half of them are going to be what you pay for and half of them are going to be free. So half of 12 is 6. So you're going to pay for 6 and you're going to get 6 free. So 6 tins you pay for and 6 tins are free because you buy 1 you get 1 free, and 6 plus 6 when you add them together will give you 12. You can always check it using the calculator. Okay, so in that case, if you're buying 6, each tin costs 83 pence, but we're using pounds, so I'm going to say 0.83. Okay, so 6 lots of those, so I'm going to times it by 6. When I do that, I can put it in a calculator, 0.83 times 6. And the answer comes out to £4.98. £4.98. Let's put the pound sign in there. That's offer A, and that's how much it is for offer A. Let's do a similar calculation now for offer B. Now offer B says that you get 3 tins when you buy 2. Now if you're good at your times tables, you'll recognise that basically if you're buying batches of 3, you'll need 4 lots of 3 to get 12, but you'll be basically paying for 4 lots of the 2, which would be 8. But if you don't like doing it like that, you can just have a little idea saying that basically you're going to pay for a tin, you pay for a tin, and then you're going to get a free tin. Yes, 3 tins for the price of 2. So you pay for 2 and you get 3 tins. And you could find out how many of those you need to do until you get to 12. So we have 3 plus another 3 is 6, plus another 3 is 9, plus another 3 is 12. So now you can see that what you need is you need 1, 2, 3, 4, 5, 6, 7, 8 tins that you're going to pay for, which tells us that each of those tins is 59 pence. And once again, put into your calculator, 8 times 0.59, which gives us an answer of £4.72. Now we can actually see which is the cheaper option, because we can compare A to B. We can say that £4.98 or £4.72. We can see that cheapest one is offer B. So she should buy, sorry, let me push it up here so you can see what I'm writing. Offer B. Let's just read what they said. It just says which offer should you choose. They're not asking for anything else, and it's quite clear they can see there which is cheaper. We've shown our workings. Okay, brilliant. Let's move to part B. Part B is again quite a long one, 4 marks. And they tell us that Joe stacks the shelves in the supermarket. So this is a shelf, and he's putting cereal boxes, as you can see in the picture, the cereal box on the shelf. The base of each cereal box is 21 centimeters. So in other words, this distance here, 21 centimeters from that side to that side. And it's 6 centimeters, so in this direction here it's 6 centimeters. Okay, it's a rectangle. The base of the cereal, as you can see, the top is a rectangle, so the bottom is also a rectangle. 21 centimeters and 6 centimeters. They tell us that the top of the shelf is 150 centimeters, as you can see in this picture, and it's a rectangle, so in this direction is 48. And you can see here they've drawn the cereal box 21 across and 6 in this direction, like I've done up there. It says only one layer of cereal boxes can be put on shelves. What they mean is that they're not going to put one on top of another. They're just going to put them behind each other or beside each other, okay, but not on top. Work out the maximum, that means the most, the biggest number of cereal boxes that Joey can fit on the shelf. Show your workings. Now there's different ways of doing this, but since they've given us some diagrams and we have a calculator, you can just, the quick way would be to find out how many 21s fit into 48. So if you're doing a kind of more mathsy way, what you would say is in that direction, you had 48 centimeters and divide it by, sorry, my mistake. Divide it by the width, which is this bit here, 6. Put in your calculator and you have 48 divided by 6. Oops, make sure 48 divided by 6, 8. So you can get 8 cereal boxes in this direction, so you can have 8 fitting in this direction. 1, 2, 3, 4. Obviously I can't draw them all there, but you can see 1, 2, 3, 4, 5, 6. You'd get 8 in this direction. Okay, so you can get 8 boxes in that direction. The other way you could do it is you could go adding 6 plus 6 plus 6 plus 6 plus 6 until you get to 48. So you could do it that way. Now we want to find out how many fit in this direction. So we're going to say we have a total width of 150 centimeters and we're going to split it into 21s because we want to find out how many of those 21s fit along in that direction. Okay, so 150 divided by 21 gives a fraction, and when I convert it to a decimal it comes out to 7.14 etc. 7.14 etc. Okay, but remember you can't cut a box. Nobody would want to buy part of a box. So what we're going to say is that basically you can fit 7 boxes in that direction and you can fit 8 boxes in the other direction. So you can have 7 boxes in this direction, there'll be a bit of space left, and you can fit 8 exactly in that direction. So in total, we would have 8 lots of 7. 8 times 7, 56. So he would be able to fit in a total of 56 boxes. There are different ways of doing it, but the answer should come out to 56. So we've done question 8 part B. Let's have a look at question 8 part C. Question 8 part C is again 5 marks, and this time they're telling us that here are some items that Joe buys after work: a loaf of bread, a carton of milk, a tin of beans, a bar of chocolate, and the prices. Notice some of them are in pounds and some of them are in pence. Joey gets 20% staff discount off the price of his shopping. He pays with a £5 note. How much change should he get? Now for 5 marks we need to show our workings, even though they haven't asked for them. So first thing we need to do is find the total. But remember that you don't want to work with pence, because otherwise it won't work. Let's change it into pounds. So that's there is going to be 0.65 pounds. So when we want to work out the total will be adding everything together, which is going to be £1.10 plus £1.15 plus 0.65 plus £1.20. Remember to enter it into your calculator with care, making sure you're putting the decimal point in. Okay, the nice thing of these calculators, you can always check that you haven't made a mistake. And that comes out to 4.1, in other words 4.10. That's how much he would pay full price, but he gets a staff discount of 20% off. So now you have to work out the percentage, and to do that you're going to work out 20% of the amount. So we're going to say 20% of, sorry about that, you can't see that, 4.10, and it comes out to 0.82. 0.82. So that's the money that is going to come off. Off means you're going to subtract it. So you're going to say £4.10 take away 0.82. So we're going to have £4.10 minus 0.82, and the answer comes out to 3.28. So that's going to be £3.28. That's what he pays. But the question wasn't how much does he pay, the question is how much change should he get. So the last bit is a subtraction where you have your £5, take away £3.28. So we're going to say £5, take away £3.28. We end up with £1.72. Now the final answer has a pound sign, so I can just write it in, £1.72. That's worth 5 marks, so it's a really good idea to set out your workings carefully when you do that. Okay. That was question 8, which means we're now on to question 9. We're talking about a gardener. And the gardener, Ellie is a gardener, she does gardening jobs. She uses this formula to work out how much to charge in pounds for the job. 11.25 times the number of hours plus 12.5 or 50. Customer wants to pay no more than £80 to have his garden tidied. Work out the maximum number of hours Ellie can work on the garden. 3 marks for this question. So this is a trial and error one, where you could try different things out and see how much it comes out to, or you could work backwards. So you could work backwards by working out that that's a charge with £80 and working backwards to find the number of hours, but we're going to do it by trial and error. Okay, now notice there's a multiplication and an addition. If you're using a scientific calculator like I am, it will do the order of operation automatically, but if you're using a more simple calculator, make sure that you do the multiplication part first and then afterwards add your £12.50 onto it. Okay, so the first one I'm going to do is I'm going to say number of hours was 1. And so the calculation for that would be 11.25 times 1 and then add £12.50. So we're going to do 11.25 times 1 plus £12.50. Okay, and I'm just doing it all in one go because I have a scientific calculator. And it comes out to £23.75. Now clearly they can do it for more because she has £80 to spend and she wants to find the maximum. So we can repeat it for 2 hours. So we will do the same calculation again, times 2 to see what it comes out to. So 11.25 times 2 and then add 12.5 to it, and it comes out to 35 this time. Okay. So now we're going to say 3, so we're going to 11.25 times 3 plus 12.50. So 11.25 times 3 plus 12.50, and this time it comes out to 46.25. Now you don't have to keep doing that, you could just plug it into your calculator and see at what point it works, okay? So I'm going to jump because clearly that's going to take quite a while. See, I've gone up 3 hours and it's gone up, and so I'm going to do a jump. I'm going to skip 4 and I'm going to go to 5, okay? Because we want to kind of get there a bit faster. So we're going to do, sorry about that, just caught it. So we need 11.25 times 5 plus 12.50. And this time it came out to 68.75. A bit closer, but we still can get closer. So I'm going to skip 6 and I'm going to try 7. So 11.25 times 7 plus 12.50. And this time the answer came out to 91. Okay, so I went too much. Okay, so that was £91.25. So that didn't work. So I'm going to go back to 6 hours. Shows that sometimes it's better to just go slowly instead of trying to be clever and jumping like I did. So let's try that. 11.25 times 6 plus 12.5. And that comes out to 80. Now sometimes it will come out exactly as it has in this case, but sometimes it won't. And if it doesn't come out exactly, you obviously can't go over, so it's the thing that would be closest to 80. So in this case this worked, so that tells me that it's 6 hours. 6 hours is the maximum number of hours. Actually, I didn't need to write hours twice because I'd already written it, but never mind, we've done that, so we can just leave it. That's part A. This is part B, and part B is a different customer wants Ellie to spread some fertilizer on the lawn. Lawn is the grass and fertilizer helps the grass grow better. A shop sells these bags of fertilizer, so if you buy this bag it costs £2.95 and it has 750 grams inside. Ellie uses 40 grams of fertilizer for every square meter of lawn. In other words, 1 meter square. That's what that means there. So every time she has 1 meter square of lawn, you will use 40 grams of fertilizer. The area of the lawn she's using is 145 square meters. Okay, so she's got 145 meters squared. So we want to find out if she uses 1 meter squared of this, she needs 40 of that. Okay, so, and we have 145 of these, so we have 145 lots of 40 grams. So that's how much fertilizer she will need, which is quite a bit, as you can see, 5,800. So she needs 5,800 grams. That's what she needs. So the question is, how many bags will she buy? So we're now going to split them. So you could go counting 1 bag plus 2 bags plus adding these until you get to that. But the easiest way to do it is a division. So we have an answer that was 5,800 divided by 750. I can do that because they're both grams. Divide by 750, which comes out to 7.73 recurring. Recurring just means it repeats itself. Okay, so it comes out to 7.73, and the 3 just recurs, it keeps going forever. So this is the number of bags of fertilizer she will need. Now in this case, it's not a full number of bags, but remember, you can't go into a shop and buy part of a bag. So this means that to have enough, she will need to buy a total of 8 bags. Okay? But the question was not how many bags does she need, the question was how much will it cost? And in this picture, we can see that each bag is £2.95. So if she's buying 8 bags, she's going to pay 8 lots of £2.95. So 8 times £2.95. 8 times £2.95 comes out to £23.60. £23.60. Okay, so then we just have to write the answer down here, £23.60. Always make sure that your decimal dot is quite clear. Excellent, that was 9b. So we're now on to 9c, and 9c is Ellie records the number of hours that she works each day, and here are 6 days, 1, 2, 3, 4, 5, 6, and she says, on average, I worked more than 7 hours per day. Now remember, average is the mean in this question, and the mean means add them all together to find the total. So to do that, we're going to add them all together to find the total. Okay, that will give us a total, and then at the end you divide by how many. Why am I doing that? Because I want to find out what her mean or what her average was, and to see if it was more than 7 hours per day or not. So now let's add them together. So we have 6.75 plus 10 plus 5 plus 8 plus 6.5 plus 9. Okay, so we added all the bits together and we ended up with £45.25. Sorry, talking about hours. 45 hours, 0.25. So the mean will be 45.25 divided by how many? And they told us, we can see there are 6 of them. So now we just divide that by 6. And it comes out to 7.741. So let's keep that there to write it down. 7.541.6. And the 6 just keeps going and going and going and going, and it's recurring forever. Okay, and that's how many hours she worked on average. And the questions said, is she correct? Because she said that on average she worked more than 7 hours, and you can see this is definitely more than 7 hours. It's 7.5, so that's more. And so we can say yes, she is correct, because 7.5 is bigger than 7 hours. Excellent, 3 marks for that. Oh, a new question, question 10, talking about ice cream. Tanya makes and sells ice cream. In part A, it says, these are her ingredients to make vanilla ice cream. These ingredients will make 1 litre. She has double cream, milk, sugar, yolks, and a vanilla pod. Tanya wants to make 3 litres of vanilla ice cream. Okay, so if this is enough for 1, she'll need 3 lots of this to make enough for 3. Yes, so in other words, we're going to times it by 3. Because if we times it by 3, it will come out to 3 litres. Yeah, 1 times 3 is 3. So it means that each of these we would have to times by 3. Let's make my multiplications a bit more obvious. So each of these would have to times by 3. Okay, but I'm not going to do it yet because I haven't read the question. I'm just understanding what would happen if we wanted to make 3 litres of vanilla ice cream. We need 3 lots of everything. In the question it says she has 800 grams of sugar, 13 eggs. She has enough of all the other ingredients. So the ones we're going to focus on are the sugar and the eggs. Everything else she has enough of. How much more sugar and how many more eggs does she need? Now the point is, we need to find out how much she needs then to make 3 litres of ice cream for sugar. So for that one we need 275 times 3, which comes out to 825 grams of sugar. And 5 times 3, well, I can do that in my head, that's 15, but if you're not sure, just put it into your calculator. And that's how many eggs she needs. So we need 3 lots of that to get 825 and 3 lots of 5 to get 15. And they tell us that at the moment she has 13 eggs and 800 grams of sugar. So to find out how much more she needs, well, she needs 825, but she already has 800, and when you put that in your calculator, it will come out to 25 grams that she needs. And we also can see that she needs 15 eggs. She already has 13. When you put that in your calculator, 15 minus 13 will tell you 2 eggs. And that's how much sugar. So the question is, how much more does she need? Down here we have the space for sugar and for eggs, and it's in grams. So she needs another 25 grams of sugar, and she needs another 2 eggs. Not so bad. On to part B. What does part B say? Part B says that she has tubs that she puts her ice cream into, and here's a tub. Looks a bit like a cuboid. She has 18 litres of ice cream to put into these tubs. They tell us that 1 litre is the same as 1,000 centimetres cubed. Work out the number of tubs she needs for this ice cream. You must show your workings. Well, the first thing we're going to do is we're going to work out the volume, and the reason is I can see that I need to work with capacity, how much stuff it can carry, and so I'm going to work out the volume of that shape of that cuboid, which is going to be 15 times 12.5 times 8, and they're all in centimeters, so I can do that. So 15 times 12.5 times 8, and that comes out to 1,500. 1,500 centimeters cubed. That's a volume. So that's how much one of those tubs will carry. Okay, but she wants to put 18 litres in, so we now need to find out how many centimeters cubed 18 litres has, to then compare to how many of these we have. So we're now going to say, well, she had 18 litres, and each litre is 1,000 centimeters cubed, and when you multiply those together, you're going to do 18 times 1,000. You end up with 18,000. Okay, so that's how much ice cream she has, and we want to find out how many of these she needs to fit all that in. So it's going to be a division. So you have 18,000 split into 1,500. So 18,000 divided by 1,500 tells us we need 12. So 12. The question is, how many tubs does she need? The answer down here will be she needs 12 tubs of ice cream. That's how much she'll need to put all that ice cream into. There are other ways of doing it, okay? If you have a better way of doing it, please do that, but the answer will still come out to 12 tubs. Whichever way you do it, it should come out to 12. If it's not 12, then you've made a little mistake somewhere along the line. Okay, part C for question 10. Tanya sells scoops of her ice cream. One day she sells 4 flavours. We can see there's vanilla and strawberry, but we are missing the other 2 flavours. The bar chart shows information about the number of scoops she sells. How many scoops for vanilla and strawberry? Okay. We can see that the vanilla, if you count the number of things going up here to get to 10, you go 1, 2, 3, 4, it only gets up to 5, so each little square isn't worth 1. Let's try 2. 2, 4, 6, 8, 10. Yes, so each little square here is worth 2. So when we do that, we're going to get 10, 20, 30, 40, 42, 44. So the height of this one here is 44. Okay. When we come to do this one, 20, 22, 24, 26, 28. And the height of this one here is 28. So 28 scoops of strawberry, 44 scoops of vanilla. Tanya sells a total of 112 scoops of ice cream. She sells half as many scoops of toffee as strawberry. The rest of the scoops are chocolate. Complete the bar chart. Okay, so we're going to use this information here. She sells half as many scoops of toffee ice cream as strawberry ice cream. We know she has 28 of strawberry. So 28 divided by 2, because half is the same as dividing by 2. And when you put that into your calculator, it will come out to 14. So we know that there's 14 scoops of toffee. Okay. So when we come to draw that, we're going to draw it on here. Now we have to be careful that we follow the same gap. So there's a gap of 5 and then a bar of 5, gap of 5, bar of 5, so gap of 5. So the next one will start there and finish there. And it needs to go up to 14. So 10 is that line there. Then we have to go 10, 11, 12, 13, 14. So we're going to go as high as that bit there. Okay, and the same here, going to go up. And then we're going to basically make sure it does line up with the line nicely. Okay, and then label it. This one here will be toffee. Okay, right, but we haven't finished because they told us there were four bunches and we only have 3 bars at the moment. So in total there's 112. So we're going to start with 112. We're going to take away from it 44 for the vanilla. We're going to take away from it 28 for the strawberry, and we're going to take away from it 14 for toffee. And I'm going to go back up here and just write 14. Okay, it's a calculator one, so we can do it all in one go. 112 minus 44, take away 28, take away 14, and it leaves us with 26. So we have 26 left over. Okay, and they tell us that the rest, what's left over, is chocolate. So we're going to put in this bit here, chocolate. Okay, and it's going to be 26. So it's going to go 10, 20, 22, 23, 24, 25, 26. It's going to be up to that point there. Just make sure we can see where it's going up to. It's going up to there. And this one here will go up to there. Now we're going to draw it. And there. Okay, and that one there is meant to be 26. Excellent, we've labelled it, we've got the right heights, we've got 4 bars and the gaps between them are all the same. Excellent, well done, 5 marks for that. So where are we? We're on to question 11. Question 11, part A is talking about airplanes and hobbies. Callum is painting a model plane. He has 60 millilitres of white paint and some black paint. He uses 2/5 of the white paint on the wings. He then wants to make grey paint by mixing the white paint with the black paint in a ratio of 4:1. Callum uses 10 millilitres of black paint. Does he have enough white paint? Okay, 4 marks for this one, so let's have a look at it. So the first thing we know is that he has black paint and there's 60 millilitres of that. Okay, and they tell us that he uses 2/5 of the white paint on the wings. Okay, well notice that's different. That's black paint, that's white paint. So we have to find out some more information, okay? He then wants to make grey paint by mixing white with black in a ratio of 4:1. Callum uses 10 millilitres of black paint. Does he have enough white paint? Ah, okay. Now I made can you see what I did? I didn't read the question, did I? Here I marked black paint, but this is actually here white paint and some black paint. So this is not what I meant to underline. I was thinking, how can we work out 2/5? That's why I was getting confused. But here we have 60 millilitres of white paint and he says 2/5 of it is used. So now we're going to work out 2/5. 2/5 of 60, and you can do that on a calculator by saying 2/5 of 60. Remember, you can multiply to do that. Can you see there? 2/5 of times 60, and when you press equals it comes out to 24. So that's how much white paint he uses on the wings. So we can now find out how much is left, okay? And what's left will be the 60, take away the 24 that he uses on the wings. 60 take away 24, which leaves him with 36. So this is how much he's got left. Okay, white paint is left. They then tell us he makes some grey paint and he does it by mixing 4:1. So he has 4:1 and the ratio is white to black. So the first one is white, the second one is black. So the first one is white, the second one is black. Okay, and how much white does he have? He has 36. Notice I'm keeping in the white side the 36, and we want to find out if 10 millilitres will be enough. Okay, so what we need to do is we need to find out 4 times what is 36, so we can go backwards. 36 divided by 4, which tells me 9. So this side is 4 times 9 is 36, so we'll do the same on this side. Times 9. 1 times 9 is 9. So he needs 9 milliliters of black if he uses 36 of white. And the question was, did he have enough? Because it says Callum uses 10 milliliters of black paint. Does he have enough white paint? Oh, again, I haven't read the question, have I? Let's go back to the drawing board. It wasn't that he uses all of that white, it was that he uses 10 milliliters of black paint. So let me write 10 on this side. Okay, so he uses 10 of that. So 1 times 10 is 10. So he's going to go on this side times 10. 4 times 10 is 40. So if he's going to use all of the black paint, he'll need 40 milliliters of white paint. And the question is, does he have enough white paint? No, he doesn't, because he only has 36 milliliters. So no, he needs 40, but only has, let me push this up so you can see what I'm writing, only has 36. Okay, so basically no, he needs 40 milliliters of paint, but he only has 36 milliliters of paint. 4 marks for that question. Okay, part B, we're nearly towards the end, only 2 questions left to go. Callum wants to make a model toolbox out of cardboard. The toolbox will be a cube. Okay, cube, remember all sides will be equal, and they tell us that each side is going to be 3 centimeters. He will cut out a net. Now a net is when you open up a cube to see what it looks like, of a cube to make the model. The centimeter grid below shows a piece of cardboard he wants to use. By drawing a net, check that the piece of cardboard is large enough. So we're going to have to draw a cube, a net of a cube. Okay, so what I'm going to do is I'm going to start at the edge to see that things fit. Now if you think about it, we'll have 3, give yourself enough room. Okay, so I'm going to go, for example, here-ish. I'm going to draw one of the faces. Remember, cube has 6 faces, front, back, top, bottom, side, side. Okay, so I'm going to draw the first square, which will be one of the sides of the cube. Okay, so there's the first one, and then we need another, so that's going to be the side, that will be the back, that will be the other side, and this will be the front. Okay, and it needs to go up to 3 for each of those. Okay, now there's different ways of drawing this, but the thing is you must have 6 faces, because, and when you open or close it, it must be able to fit. Now the typical way of doing it is this way, so I'm then going to go up 3 and down 3. And over here I'm going to go up 3 and down 3, and it's like a cross, because then this will be the bottom of my cuboid, and this one here will be the top of my cuboid. Okay, so that's one face, that's another face, that's another face, another face, another one. Okay, have they asked us to label it? It just says, by drawing a net, check the piece of cardboard is large enough. Well, it's clearly large enough. There's a lot of space left there, and so we're fine. We don't need to put any labels. They haven't asked for it. Okay, excellent. Last part, I think. Let me. Oh yes, last part, because it says here end of questions. So question 11C. Callum also collects stamps that have pictures and planes. That have pictures of planes. He sees a pack of mixed transport stamps for sale online. The pack has this chart to show the proportion of each one: planes, train, car, boat, and it's a pie chart. Callum says less than 10% of the stamps have pictures of planes. Is he correct? Okay, so we need to find out 10% of a full circle and then see if this is matching to what it is. So we're going to find out 10%, and 10% is 10 out of 100 times, now for the full circle it's going to be 360 degrees in a full circle. So 10 out of 100 times by 360. Make sure the numbers are all correct. Yeah, gives us 36. So, degrees. So, if when we measure this bit here for planes, if that is less than 36, he is correct. But if it's more than 36, he's wrong. So now we're going to have to measure it. Now when you measure that, it depends on which protractor you have and how you do it. I'm going to make my lines a little bit longer because my protractor today is a very big one. If you have a smaller protractor, you don't need to do this, okay? But because I have a big protractor, I will actually need to be able to see where the lines are when I come to measuring, okay? So to do that, remember, you're going to find the center of your diagram. And the center of your diagram lines up with the center of your protractor. So in my case, it's this dot here, but sometimes you have a cross. So I'm going to put that on top of the center. And you must align the 0 with your starting point. So there we are. Make sure it's over the dot. There we are. Make sure it's aligned. Okay. And then we're going to count. And we have 10, 20, 30, 40, 50. Sorry if you can't see that very well, but basically that's a 50. So the angle here is 50 degrees. So he said that less than 10% of the stamps have planes. In other words, he said that this would be smaller than 10%. 10% was 36, as we just calculated. And in this case, he's wrong because 50 is actually bigger than 36. Okay, so 36 is smaller than 50 degrees, which we measured. Is he correct? No. 50 degrees is bigger than 36 degrees. Okay, and that's the end of that. Well done. Hopefully that's been useful. Bye.